So we've got a controller from a Neff, or should I say Neff, integrated washer dryer. It's blown up. I actually bought another one of these off the internet for 99p locally. It was also, when I plugged it in and tried it, it didn't work either, and it has the same fault. So I'm guessing this is the first one I've looked at, so I've never looked at this piece of hardware before. But this one is the one from a flat of a friend, and the display was playing up. He put up with the work. He could work out what was going on by deciphering the display, but there's several segments out on this display. I've ordered a new display for it in the hope that I can fix it for him. Yeah, it's just going click, 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 click. I think from you've seen from my previous videos, the power goes in there. This is it's an ALPS switch. ALPS control switch, and this basically is the main switch. So the mains goes in there, and there's no mains on the PCB mains power until that switch is turned. And what we've got here is obviously the switch mode power supply section, a couple of fusible resistors, some filtering, a couple of connections for a heating element connected by a relay. So there's various relays here to control the mains power to the peripherals. Remember, it's a washer dryer, so there's a drying heater, there's a condenser valve, there's the motor, there's a water inlet, and the drainage pump, and then various sensors. And you can see actually there was quite a lot, when I unplugged this, there was plugs in most of these, and it's really quite a lot of interfaces on this board. There's the micro, look. You've got your high voltage main smoothing capacitor. If I zoom in a little bit, you might be able to see a bit better, mightn't you, what I'm talking about. Alright, so let's just run over it. A couple of fusible resistors, a linear... Is that a switching FET or is that a linear regulator? This chip, I'll show the data sheet in a minute. If I turn that around that way, you can see it's a TNY68PN, 268PN, TNY 268PN. It's basically an offline, actually it's not offline because this is a proper switch mode power supply with an isolation transformer. So that's the switching transformer. And then on the back of the switching transformer you've got two diodes, one there for 1 voltage rail, probably 5 volts for this or thereabouts, and another diode here going through this filtering to another cap which is probably the 12 volts for the relays. At the moment I'm not sure what this is, whether this is using a switching FET to boost its capacity, although I don't see why it would need it because it's just got to power 1, 2, 3, 4 relays, 5 relays. So they're what's the code? It's probably probably 100 milliamps each coil or something like that. So you've got 500 milliamps. So you've got probably a 2.5 watt supply required for this because the micro won't take very much, and maybe 200 milliwatts for the display. So it might be up to 0.5, 0.6, 0.8 watts of display power, DC power. So I'm not sure. Is that connected to the? It seems to go to the switching transformer, doesn't it? Under here, one of these connections, and it's on the high voltage side, which is this side. There's the opto-isolator feedback to this to actually feed back the actual secondary voltage from the smooth supply to control demand and their closed loop regulation. Yeah, I'm not entirely sure if that's the FET. I can't see the number on it. It's been sprung load clamped into here. I could get it out and have a look and see what it is. It doesn't. The fact it's got heatsink on it might suggest it is switching. This is a very cheap current sensing plane, I think, or a heatsink, or both. It's an odd thing. It's live. It's metal. It might be a 0.2 ohm resistor for current sensing on this side of the thing, or it might just be cooling for this chip, although these don't normally necessarily have cooling requirement, but I'm not sure at the moment, so I'll investigate that further. So is that a combined heatsink stroke current shunt to sense the current, or is this just a something to dissipate some heat away from the chip? It's mounted extremely close to the legs of the chip. All those legs on that chip are all connected together, are they? No, they're not. But you can see it goes to 2 legs of the chip, the switching side input, so it could just be heat sinking or current sensing, I don't know. It's a big bit of metal, isn't it, for a 0.2 ohm, and appears to be brass, so it's probably just a heatsink. Nasty live heatsink, hate that. Yeah, so of course the normal cause of problems is these offline switching chips go. They don't really tolerate a rush of input voltage, and if you get a surge down the mains, they go wrong. However, I'm rambling on a bit here, but I do know that these condensing dryers, and I think this is what happened to this one, is subject to condensation because the hot, moist air is pumped around the tumble dryer internally and condensed. And if there's any leaks on the manifold and the ducting at the top, you can get condensation. And the chap who owns this did say he saw some condensation on the inside of the plastic, so it could have been the condensation which blew it up, which is probably there's no signs of any I can see on this board of any, you know, when you get condensation you get electrolytic action, because even 5 volts will burn out the wires and things if there's a voltage you know, by electrolysis. And I've seen many circuit boards of just the 5 volt sides have got damp, and they, you know, it's eaten through the wires and etched away at transistors and tracks and things like that. But the first thing you would expect, or you would suspect, would be high voltage. So this is the high voltage section. Remember, mains coming in through a rectifier to probably 340 volts on UK mains, 360 volts, and then switch through the primary of this transformer by this chip to a secondary side rectified by these 2 diodes, 2 different smoothing capacitors, and a 3rd smoothing capacitor. 2 of those in parallel. Yeah, 2 are in. Oh. No, but there's 1, and then it goes through a coil to the second one, I think. So some filtering there, and then feedback through this opto isolator to the input of that to the demand pin, and then some other filter capacitors, and is filtering to stop the main switching noise being transmitted back down and radiating out the mains cable and interfering with your electronic devices. Now, yeah, I mean, it's got no common mode choke. I'm not sure if that's a thermistor or what that is. It's probably to limit the inrush current. It's probably a thermistor, or it might be a varistor, an overvoltage varistor to soak up any mains transients that come down. Yeah, they are. Alright, okay, so there is some protection, but not much of anything else. And the job of these resistors here, especially that one, probably, is to blow open circuit. It's 10 ohms, and if you give it a catastrophic failure of the mains here, it'll blow these open. You'll see the little metal film blown and the ceramic covering of the resistor blown off, and they just blow open circuit. Or it could be that one there. Anyway, the bottom line is I could sketch out the schematic. We could have a look at the data sheet in a minute, but let's just plug it in and see what happens, okay? Now on these switches, if I turn it back around the other way, on here, I think you've seen the other videos, this is isolated mains. It goes through a power meter and then through an isolation transformer, a 1-to-1 ratio isolation transformer, so neither of these two are live or neutral. I can touch one of these and touch ground, touch down to that one and touch ground, and I don't get a shock. And also, more importantly, I can earth my scope probe, so the 0 volt line of my scope probe can go on the AC 0 volts. Normally that would be sitting at neutral or half mains. In either case, if you connect your scope up to it, either it will go bang, or if it's just half wave bridge rectification, the AC 0 volts will just trip your RCD in your switch box if you have one, because you've got suddenly you made a connection through the scope probe to neutral, and there's an imbalance and it trips out, so it'll trip out your power. So this is isolated, so it's the safest way to work, so that's what I'm doing. So we just stick it onto the top of this switch there, in there, and if you are working on mains powered stuff, watch out. You know, you better make sure you know what you're doing, because I can't take any responsibility if you don't know what you're doing and you try this and you get a nasty shock or worse, okay? So please ensure that you understand the issues, the safety issues, otherwise don't try this. So by putting an ordinary number 1 cross point screwdriver in, which is this, into there, don't know if you can see, but it actually, you can use it as an actuator. Okay. So if I just turn it on, it's off now. If I turn it on, keeping my hands clear, can you hear that click, 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 click? That's a classic switch mode power supply issue, and sometimes or often it can indicate that you've got a short on the secondary side, and this thing is feeding back too much current being drawn. It shuts down again. It's trying to start up. That click, click, click as it's trying to start. So first things first, is there an overload on the DC side? There could be, but what I'm going to do anyway, because these devices, let's find something plastic to poke with. Here, my tie wrap. These devices they age. They don't last more than 3 or 4 years usually, a bit longer perhaps. They're right in the fast lane or the middle of a high voltage juggernaut on the end of the main supply, and I know that there's quite a lot of failing at the moment, because certainly around here we've been getting regular power dips. I don't know if it's to do with the lockdown or whether it's just lack of maintenance, but the power goes off and then comes back on literally 10-15 seconds later, and it's when it comes back on you can get some horrible transients. Okay, so this could be blown up at that stage. The condensation, which has been going on for a while, may have nothing to do with it, but we'll discover that later. So the first thing I'm doing, I've ordered one of these. They're about £1 from, I've ordered several of them actually, just in case I need some more. In case I blow this one up and I'm trying to fix it. Not that one. Right, that's the shift register for the display. Alright, so if you want to get one from Farnell, that's the part number. Alright, so TNY268PN. And did I order more than one, or did I just order one? One I ordered. Not like me at all. But it's not a common one. It's a new version of the LNK302, which is widely used in Bosch, and a lot of stuff use the LNK range from power devices. But yeah, so the first thing to do is just quickly change that chip and see what we get. So I turn the power off, because it's clearly not starting up. There's no signs of life on the display or anything. So at the moment I'm just going to assume it's that chip, because it usually is. And if I was doing a repair, I would change it anyway. So let's just take that chip out and have a quick look. Right, so turn the soldering iron on, soldering iron, turn the power off, get my discharge resistor wherever it may be. Do you know, I'm going to have to tidy up around here at some point. Where are you, you bugger? No, I'm going to have to use the old-fashioned method, which is going to make a bit of a bang. I don't think it's a very big capacitor, so I don't think you need your mum on speed dial for this one. If I can find a decent pair of something, I'll sort it out with this. Okay, so power's off. High voltage capacitor is just there. You can see here, you can see the blackness from the dust that's been attracted by the electrostatic attraction, if you like to call that, of the high voltage. So it's this one here. It's this little bugger here. We just need to. It's not a very big cap, so it probably already discharged, but I'm not going to take any chances because I don't like electric shocks much. So it's those two contacts there. No, so it's dead now. Alright, so I've done that, and let's take that chip out then. So it's a through mounted chip there, so it's just those connections there. Unfortunately, or fortunately, the way you look at it really, you can see that whilst desoldering this chip, if I can get this to stay in a stable position, I'll take my connections off first. I'll get set up to resolder it, then we'll get on with it. Alright, so we've got this resting on a roller tape, and we're going to desolder this, and I'm going to use the mother sucker. I've had this since I was 18, believe it or not. It's a long time ago. It sucks better than a, well, can't say it. Anyway, yeah, I like to say it, but I can't. So I'm going to put a little bit of flux on just to keep things flowing, because everyone knows things go better with flux, don't they? So where are the 2 rows of pins on this thing? There's 1 pin missing. Right, okay, so there. to get my bearings. There's one pin there, looks pretty dirty, doesn't it? 4 there and 1 there, and then 3 altogether, right? And also that's that big horrible metal thing, so we're going to need some capacity in our soldering iron to melt that, and it's lead-free solder. So I got the old Weller 90 watt set to 400 degrees, and to make things go with a bit more flow, I'm going to stick in some leaded solder just to make an alloy of leaded and unleaded, because it will lower the melting point considerably and make it much more workable. You can see it's melting pretty slowly. And I'm going to add some to all the joints on this thing. There we are. A bit more jointy. There we are. Alright. Right, let it flow, and then suck it all up. Now I've blocked my tip hole. She sucks, but her hole is blocked. It's a downside of a mother sucker, isn't it? Some people call them a soldier sucker, but that was something else when I was growing up. You can see all the detritus in there. I'll just give it a bit of a reverse. Trying to remove the... Now the tips come out. There we are, so we've got a solder plug. Very solid amount of detritus in this thing. Let's see if I can get at it with something a little bit more substantial. Talk amongst yourselves. But my soldier sucker has got blocked up. Focus on that. There we are. Suck it up, bitch. Right. Here we go, here we go, here we go. See, details are emerging. If you look at that, actually, do it again, the pins have actually been soldered onto the heatsink. Actually, the heatsink and the pins are coming through the same hole, so clearly it is a heatsink. Now the fact that the LNK series probably have got more efficient switches, and this is probably a transistor based switch. That's why it needs cooling. I'm going to look up the data sheet in a minute and we'll see what it says. Bear in mind, we don't know. We don't have a clue at the moment whether this is the cause of the fault. But they do age, and it will have been stressed at some point, so just change it. While you got her out, give her a new lease of life. That's what I always say. So just free off these pins one by one, and just pulling it away from the side of the hole to free them up. Likewise with that one, still got quite a lot of solder in the hole, so let's give it another suck. It's counterintuitive, but if you put a bit more solder on, it'll dilute the lead-free solder in the hill. Hold on, mate. You're almost blocked up again. And sucky. That looks a bit better. Is that loose now? Sure if that's loose or not. But those pins are still soldered onto the heatsink. This is going to be interesting. I'm just going to heat them up and bend them down away from the heatsink. Or shunt, or whatever that thing is. And then, again, a little bit more solder, make it flow. And another blast on the solder sucker. There you go. And I can pull those up. If I do it quick, it won't rejoin onto the heatsink, and then we should be able to get that device out with a bit of luck. All things being equal. A bit of leverage. A bit of leverage here. And there she blows. Yeah, so I think there's not much to clear up on there. There's a little bit of solder there, look, just to be collected. There we go. Looking good. So where's that device? Where is that? There it is. So what's your reckoning, boys and girls? Do you reckon this is going to fix it or not? I'd say it does. Probably 3 times out of 5. But going to change it anyway because it's had a hard life. No one likes a transient. Especially one of these things. So this is a power integrations device. I have to close her legs a little bit, just give her a bit of a tweak. She's got her legs open too far, and it's making it difficult to find the hole at the moment. So let's try that. Come on, go in your new home. There you are. That's better. Right, so she's in. Let's turn her over and give her a hot supper. Right, so for this, I'm not going to use the horrible nasty blue. You see this stuff? If you've got this stuff, it's very common. Jinhu, made in China. Jinhu? Jin screw. It's B1 flux 2%, 0.8 mil. Looks shiny, looks nice, but my god, it's not very good. So where is my other stuff, which is about twice the price and 5 times as good? And this one is, guess what this one is? Multi-core 6040. It's lovely. Made in Malaysia though. Henkel. But 5-core SN 309 flux. Flows like a dream, 0.5 millimeter. And it's a different thing. This will go all stodgy and splodgy. And this goes all shiny and lovely. And this flows. I know you're not supposed to put leaded flux on unleaded components, but the quantity is so small, and to be honest with you, lead free is, I've got rolls of lead free. I do them for certain repairs where it's industrial stuff. Got this stuff, which is the green lead free, which is 99% silver, and supposed to have a tiny amount of silver in it as well, but with flux, and it doesn't smell horrible when you use it, and it just doesn't flow as good. And why use it when you don't need to? And it's only a tiny amount, and you're saving the whole lot from going in landfill. So think about that. You might be adding a little bit of flux and solder and tin lead solder, but think of what you're saving the environment by prolonging the life of this product, probably by a good few years. Okay, now right, so solder this one, and then this one was really had a big blob on it, a blob, so we're going to put a big blob back, heat it all up, let it flow, and then can you see that flux? Isn't that lovely? I mean, this flux will clear off with the old isopropanol or IPA beautifully, clean up, lovely. It'll look lovely when it's done. But you can see how lovely and shiny that is. Lead free you just would go, and goes a bit frosty, and it doesn't flow as well. So there we have it, don't we? We do. So inspect your work, make sure you've got pin 1 in the right place, down the corner there. This is the way it came. Actually, you can't do it wrong, can you? Good point, whoever just shattered the screen, because you've got 1 pin missing, and that pin there is an air gap between the higher and lower side. It's just to stop it tracking across the board. You can see they've machined out the actual board to stop leakage across that track, although it is a bit black. So I'm just going to give her a bit of a clean, give her a bit of a scrub up with the old IPA, isopropanol, and wife's toothbrush. Let it soak in, give it a bit of a rub. Back and forth in a nice, smooth, undulating manner. This is my guitar strumming hand, so I can do different rhythms. Yeah, so it's still a bit sticky, so what you do is once you've mixed it all up and made a nice emulsion of flux and IPA, and it's still got liquid, then you just hold it over the bin and just wash it. Give it a little bit of a rinse. The spin cycle, not the spin cycle. Shake the drips off. Don't blow on it though. Well, you can blow on it. Yeah, so that's what it's like when it's done. Okay, you can see there's a little bit of splattering going on here. What you also can do is, if you do blow on it, don't get it in your eye like I just did. I don't think I'll be getting COVID-19 in the eye. Right. You can just put a little bit on there and just dab it off with a piece of kitchen towel. Right, so it's all nice and clean, thereabouts. The rest of this is this has been reflow soldered in a reflow oven. It's a no clean flux, so you can see all these tide marks. I don't like those particularly, but that's the no clean solder. So, oh, look at this. I haven't touched any of that, but look, that's a bit khaki, isn't it? The way to leave the factory. Presumably it's the factory. Actually, I know it's the factory because it's a brand new machine. It was when it was put in. It's never gone wrong so far, but it's 4.5 years old now, so they're hoping to sell us a new one. And it's a fitted in one, so it only fits. So they, when I get these kitchen fitters to put these fitted built-in units in, and then really you're almost tied to, because of the door catches and everything else, it's so much simpler to buy the same model. So the fitted units tend to be compatible with their own brand, but the Neff one that this is about 900 quid. Right, can anyone spot anything else? Put an answer or a comment downstairs. Right, so nothing else which is evident or going to cause us any problems. We've changed our chip. There's a little bit of juice. Then we want to turn it on with flux all rounder because it is ionic. My dad used to call flux killed spirits, and it was like sulfuric acid or something with or hydrochloric acid with zinc, or so it was zinc sulfate or zinc chloride. It wasn't completely killed, so it was a oxidizing or reducing solution. It must be reducing. If it was oxidizing, it'd make it worse, wouldn't it? I dare say they work on different principles now. So yeah, time to try it out, eh? I'm going to turn it round that way because my main supply happens to be round the other way. So let's put some power on her and see if she still is doing the same thing, in which case it's plan B. So power into this thing on top of the Alps switch, as we said. This is isolated mains going in, and yeah, move the solder wire off the bench because it always shorts out on things. You want to get rid of your solder. Brush any detritus from underneath. You don't want it to short out on your bench. And we'll zoom out. I think it will go peep if it turns on. I don't know. The Bosch ones do, but not necessarily. Move my scope lead out of the way. Right, you ready for this? Power on. Yeah, that's interesting. I heard a relay click, did you? Oh, look! Can you see that? So, it's on pause. Does that say pause, or does that say something else? Or push? Yeah, so it was that chip. That chip had blown. So now onto the display. Why have we only got... What have we got missing? If you turn it on, does it do the thing? Does it do a complete display light up as a segment test? I used to do it on my software. No. Is it the display? Right, stage 1 is complete. Stage 2 commences. Now if you remember, this display sometimes flashes up random characters and other times nothing at all. And so this has got 2 faults on it, and the display was pre-existing fault before the actual thing stopped working completely. So the owner had been putting up, David had been putting up with the display not working, and it, in this condition without all the ancillaries plugged in, sometimes the display fires up, sometimes it doesn't, but the display is faulty. So if you have a faulty display, then look at part 2 of this video. There's another video after this one where we deal with the mending of the actual display. Alright, so if you want your display fixing, we can do that, but look at the next video, otherwise there's too much in this video for for 2 faults. Right, so I think the majority of them will be the actual power conversion chip, because honestly that's the least reliable component in the whole setup. And so if you only got power problems, then this is a video for you. If you look down in the bottom corner of the screen, down here, down this bit, I can't get my finger around, down there is a subscribe button. If you could subscribe, then that would really help me. I appreciate it. And if you're repairing your Neff integrated washer dryer or your Neff washer dryer, I'm guessing they both use the same board, and you've got an issue or a question, then I do check the comments quite frequently, mostly every day. Then leave a comment or a question and I'll try and get back to you and help if I can. But meanwhile, hopefully we can save some of these and save some expensive repair costs and keep these things out of landfill. So thanks for watching, and as I say, if you want to see the display fixed, look at the next video.